This is the screencast for section 2.8, example 7, some other inequalities. Solving an inequality involving a radical. Ms. Larson, I've never graphed something like this before. I don't even know what this is supposed to look like. Well, that is the brilliant thing about testing on a number line, is that we can get an idea of where this function occurs. In between what x values will the graph be above the x-axis or below the x-axis? So let's just start off from the bat. Critical values make the function 0 or undefined. So positive 3 will make the function 0, so will negative 1. Alright, now I know you can't take the square root of negatives, but those won't make the function undefined, they will make the function imaginary. It's different. So let's try and put this on a number line first. I'm going to put negative 1 down and then 3 down. Now I'm going to use a set of parentheses to represent the square root. Now, if I pick a number to the left of negative 1, so let's say negative 5. Negative 5 minus 3 will be negative. Negative 5 plus 1 will be imaginary. So this will have no graph. Then in between, let's see, negative 1 makes the function 0. Between negative 1 and 3, the graph, let's see, I'll pick 0. 0 minus 3 is negative. 0 plus 1 is 1. Square root of that is going to be positive. So these values are going to be below the x-axis. It's going to be negative. Then after that, from 3 to infinity, those are all going to produce positives. So I could actually draw a little sketch of this. I know, it's crazy talk. So at negative 1, the function is 0. There's no graph to the left, so I don't have to worry about that. Then between negative 1 and 3, the graph is negative below the x-axis. Oh, at 3, the graph is also 0. Good to know. And then after that, it's positive. So it's going to look something like that. So let's look on our calculator and see if we are right. Darn close. Now, if I wanted to be a little bit more accurate, I could find out what the y-intercept would be and plug in exactly 0 for x and finding out, and graph the y-intercept a little bit more accurately. But that is a very good sketch. So to answer the question, where is that inequality greater than or equal to 0? Let's see, greater than or equal to 0. So that's going to be, first of all, x equals negative 1, as well as anywhere from 3 out to positive infinity. So negative 1 is this lone number that makes the graph, or excuse me, that makes the function equal to 0. So we have to include negative 1 and then anywhere from 3 to infinity. The now try problem for example 7 is number 43. Same thing, my critical values are positive 1/2 and negative 4. So I'm going to put those on a number line. Anything to the left of negative 4 is going to make this first, well, it doesn't even matter what that first polynomial is because this square root is going to be imaginary, so there's no graph here. Between negative 4 and 1/2 is the number 0. That's easy. So this first portion would be negative, and then 0 plus 4 is 4, square root of that is positive. So that would be negative y values when I plug in an x value between negative 4 and 1/2. Then after the 1/2, I get positives. So to answer the question, when is this less than 0? Oh, just less than 0? That would be between negative 4 and 1/2, but not including either one of those. And if you wanted to graph this and check to see if you were right with your negatives and positives, go right ahead.